Welcome, this is Professor Ridge and today's lesson 5.4, Dividing Polynomials. Today's first learning objective, use long division to divide polynomials. The division algorithm states that given a polynomial dividend f of x and a non-zero polynomial divisor d of x, where the degree of d of x is less than or equal to the degree of f of x, there exists unique polynomials q of x and r of x such that f of x is equal to d of x times q of x plus r of x. So basically, so we have our function. If we divide it, the divisor times the quotient and then plus the remainder. So q of x is the quotient, r of x is the remainder. The remainder is either equal to 0 or has degree strictly less than d of x. If r of x is equal to 0, so that's the remainder. If the remainder is 0, then d of x divides evenly into f of x. That means that in this case, both d of x and q of x are factors of f of x. Okay, so if you divide it and the remainder is 0, it goes into it evenly, which means it's a factor. Okay, let's look at example 1 here. Use long division to divide a second degree polynomial. So divide 5x squared plus 3x minus 2 by x plus 1. And I just wrote this down here to remind you when you have a problem. So the first number is the dividend divided by the divisor. And when we set it up in the long division, we use the long division symbol. The first number, the dividend, goes in underneath the long division symbol. The divisor goes on the outside, and when you work it out, the quotient goes on the top. And then if there's any remainder, we're going to write it as a fraction. It'll be the remainder divided by the divisor. Okay, so let's try this. So we're going to put the x plus 1 outside, and then inside we have the 5x squared plus 3x minus 2. All right. And then determine the first term of the quotient by dividing the leading term of the dividend by the leading term of the divisor. So we're going to look at the first terms inside, first term outside, and divide those. So for step 2 there, we're going to go 5x squared divided by x, and then 5 divided by 1 is still 5, and x squared divided by x is x. And we're going to put, now the book has you putting it above where whatever the degree is. Notice this is descending order, 5x squared, 3x. So if we look x squared, x's, and then constants. So if you do 5x squared divided by x, it's going to be 5x, and they have you line it up in the x column. And then you multiply, so multiply the answer by the divisor, so that quotient, the 5x, and then write it below like terms. So it's just like we do with numbers. So we're going to say, so if I had something like, say, 347 divided by 8, I'd say, well, 8 goes into 34 4 times, and then I go 4 times 8 is 32. And then I subtract, and then 34 minus 32 is 2. And then I bring down the next number, and then if this is bigger than the divisor, I got to do another loop. Okay, so it's the same idea. So with the modification, we took the first term divided by the first term. 5x squared divided by x is 5x. Write the answer up here. Now multiply 5x times that whole divisor. So 5x times x plus 1 is 5x squared plus 5x, and we're going to write it just beneath this. And now we're going to subtract. But remember, when you subtract, you got to distribute this minus sign. So it's 5x squared minus 5x squared, which is 0. So I'm not going to write anything. And then 3x minus 5x is a minus 2x. Okay, so remember you got to distribute that minus sign. And then our next thing, just like you did with numbers, we bring down the next term. Okay, so subtract, bring down the next term. So we're going to bring down this next term, which is a minus 2. And then repeat steps 2 through 5 until the last term, until reaching the last term of the dividend. So we've got to keep going until we get to this last term. Really what we got to do is you look at the degree of this remainder part here. If this is degree 1 and the divisor's degree 1, so you have to keep going until the degree of this is less than the degree of the divisor. So again, we start to do the first term divided by the first term. So what's negative 2x divided by x? Well, that's negative 2, and we're going to put it in the constant column, negative 2, and then multiply negative 2x minus 2. Then we subtract. Remember, you're going to distribute that minus sign, so negative 2x minus a minus becomes plus, so that'd be 0. Negative 2 minus a minus 2 is negative 2 plus 2, which is 0. So your remainder is 0. So our solution then is, so 5x squared plus 3x minus 2 divided by x plus 2 is equal to 5x minus 2. Now, using the division algorithm from the last page, we can say, so basically our dividend was the original function, and then it's the divisor times the quotient plus any remainder. So on this one, we can also say, using the division algorithm, 5x squared plus 3x minus 2 is equal to the divisor, which was x plus 2, times the quotient, 5x minus 2, plus the remainder, which was 0, so plus 0, but I'm not going to write that. Okay? So you can do it either, and if you want to check your work using the division algorithm, you just multiply these two and just verify that you end up with 5x squared plus 3x minus 2, which you do. All right, example 2, using long division to divide a third degree polynomial. So again, the dividend goes inside, so that's the first polynomial, 6x cubed plus 11x squared minus 31x plus 15. Now it's important that you write this in descending order, so if it's not given to you in descending order, you want to rearrange it so it's descending order, and it's a good habit to put zeros in for any missing terms. So if I had like 6x cubed minus 31x plus 15, then I'd put a 0 in the x squared column, just to kind of as a placeholder. It's not necessarily required, it just makes makes it a little easier for lining up the degrees. Okay, so again, first step is we're going to take the first term inside divided by the first term outside. So 6x cubed divided by 3x, so that is 2x squared, and we're going to put it in the x squared column, so 2x squared. Now you're going to take that answer, I guess this is step 2, then we're going to take that answer and multiply it by the whole divisor. Okay, so 2x squared times 3x is 6x cubed, and again, line it up in the right degree. 2x squared times negative 2 is negative 4x squared. Then we're going to subtract, so 6x cubed minus 6x cubed is 0. 11x squared minus a minus, so that becomes plus. 4 would be 15x squared. Bring down your next term. This is a degree 2 polynomial now. This is the divisor's degree 1, so we got to do another loop. Okay, we got to go all the way to the end of this. So this is going to take 3 loops. All right, so again, first term inside, 15x squared. 15x squared divided by 3x. So 15 divided by 3 is 5. X squared divided by x is just x. So we're going to do plus 5x. And notice I'm putting it above the x column. So x squared, x, constant. Okay, then multiply. So 5x times 3x minus 2. So that would be 15x squared. Now the whole point is that first term better match up, because that's the point of dividing the first term, so we can cancel out that first term. And then distribute. 5x times minus 2 would be negative 10x. Now we're going to subtract. 15x squared minus 15x squared is 0. Negative 31x minus a minus, so again that's plus. So negative 31 plus 10 would be negative 21x. Bring down the next term, and then we got to do another loop. We got to get all the way to the end is the way the book describes it, but again, technically you got to look at the degree. So the degree of the remainder has to be less than the divisor. They're both degree 1, so you got to do it one more time. Okay, first term inside, so negative 21x divided by 3x. So that is negative 7. That goes up here. And then we multiply. And you don't have to write this down. I'm just showing you what I'm doing. Just in your head, you can negative 7 times 3x minus 2 and then write the result just below the last one you were working with. So negative 7 times 3x minus 2. So it'll be negative 21x. Negative 7 times negative 2 is positive 14. And then remember, we're subtracting. So normally what I do on my paper when I'm not showing my work to students is I would say, okay, how do you subtract polynomials? You change it to add the opposite. So we change all these signs like that. So negative 21 plus 21 would be 0. 15 minus 14 would be 1. Okay, so you can do it either way. Okay, so that would be 1. All right. So now, let me erase all this scratch work here. So now, again, our solution would be 6x squared plus 11x squared minus 31x plus 15 divided by 3x minus 2 is equal to 2x squared plus 5x minus 7. And the remainder, you're going to write it, the remainder over the divisor, which is 3x minus 2. So you can write it 1 divided by, just like we do with the fractions. Okay. And then again, if I want to do the division algorithm, it's going to be the original function, the dividend. Oh, that should have been a cubed. (11x squared minus 31x plus 15) equals the divisor, 3x minus 2, times the quotient, which is 2x squared plus 5x minus 7, plus the remainder, like that. Okay, so if you distribute this out, you'll get 6x cubed plus 11x squared minus 31x plus 14, and then the plus 1 will get you to the 15. All right, so leave that for you to try it on your own just to check. So that's the way you could check to make sure you did the division correctly. Okay, on to synthetic division. to divide polynomials. Using synthetic division to divide polynomials, since synthetic division is a shortcut that can be used when the divisor is a binomial in the form of x minus k, where k is a real number. So it's really important. You can only use this if it's x minus k. There's a couple tricks where if that leading coefficient's not 1, that you can still use it, but you got to be careful. Technically, the way it's written, it has to be x minus a number or x plus a number. Okay, so k is the opposite of this sign. So in synthetic division, only the coefficients are used in the division process. All right, here's how to do it. Let me copy the example 3 and then I'll show you. Okay, using synthetic division to divide a second degree polynomial. Use synthetic division to divide 5x squared minus 3x minus 36 by x minus 3. So k is the divisor. So notice we're dividing by x minus 3. This is the divisor. And k is going to be the opposite of minus 3. So k is going to be equal to 3. Okay, so that's first thing to note. And the way that we do it, at least the way I do it, so my notation is a little different than the book's. The book does it like this. They'll put the 3 and they write it this way. And then you're going to put, I guess I can do it this way. I'll adapt. The way I do it is I write it like this. And then I put a line like that. So either way, it doesn't matter. It's just whichever way you like better. And then you're going to put the coefficients of the dividend, write the coefficients of the dividend on the top row. Okay? So we got our k, or divisor, 3 here. And then it's important to know this has to be descending order. So it's x squared, x, constant. So it's 5 for the x squares. Oops. Let me try that again. 5, negative 3, and then negative 36. So if I'm doing it the way the book notation, 5, negative 3, negative 36. And then now bring down the lead coefficient. So the first term comes down. So you just bring it down. Then multiply the lead coefficient by k, write the product in the next column. So this bottom row is going to be our quotient, right? This will be the answer. And then this middle row here is where we're doing the work, where we're going to, the scratch work, so to say. So 3 times 5 is 15. And then you're going to add the terms in the second column. So negative 3 times plus, we got to add down the column, sorry. So negative 3 plus 15 is 12. And then you keep going, 3 times 12. So you always multiply by the divisor on the bottom row and then write the result in the next column. Okay, so 3 times 12 is 36. Add down the column, so you're always adding down the columns. Negative 36 plus 36 is 0. And then this is your remainder. So if the first column was x squared, then it descends, so it's x squared, x, constant. And then on your solution, you go down 1 degree for each one. So this, since we're dividing by x, right? We're dividing by x. So the bottom row will be down 1 degree. So if the first column was x squared, on the top row, the bottom row, this would be down 1 degree. So this would be x. This would be our constant. And then this will be our remainder. Okay? So the same thing here. If I do it again, it's just different, the book notation. So bring down the first one. 3 times 5 is 15, goes in the next column. Add down. 3 times 12 is 36. Put it in the next column. Add down the column. That's 0. And then you just got to remember this is your, I like to put the box so just to know, hey, that's the remainder. So again, if this was 5x squared divided by x, this would be 5x. And then we're descending order, 12, and then the remainder. Okay, so then that's our answer. So it'll just be 5x plus 12. So again, and since the remainder is 0, that tells us that 5x plus 12 and x minus 3 are factors. So using the division algorithm, the divisor was x minus 3, and then the quotient's 5x plus 12 with the 0 remainder. If I FOIL this, you would get 5x squared minus 3x minus 36. So I can do that as a check. And then again, since the remainder is 0, 5x plus 12 was a factor, x minus 3 was a factor, right? So if you divide and the remainder is 0, that means it goes in evenly, and the factor, the divisor and the quotient are both factors of the dividend. Okay, so now let's try a third degree polynomial. This is example 4. So again, my k, you're going to switch this sign. So k is going to be -2. I'm going to use my notation, -2. So, and then I'm going to put the coefficients, and notice again it has to be descending order, x cubed, x squared, x constant. You write those coefficients down, 4, 10, -6, -20, and then leave space for your working row, and then below the line will be our quotient. So bring the first term down, and then you multiply. You always multiply by the divisor, so -2 times 4 is -8. You always add down the column, so that's 2. -2 times 2 is -4. Add down the column, -10. So it's always going to be multiply, add, and it's always, you take this number times you take the divisor times the number in the on the bottom row, multiply it, and it goes up. So it goes 4 times -2 is -8. Add down the column, 10 minus 8 is 2, and then we got to multiply. -4, and then it goes in the next column, add down the column, -10, and then multiply. -2 times -10 is 20. Add down the column, you get 0. And that's it. So our quotient is going to be, now this was x cubed, so we go down 1 degree, this would be x squared. So it'd be 4x squared plus 2x minus 10 with a 0 remainder. So that's our answer. And again, if we want to write it using the division algorithm, so the original number, the dividend, is equal to the divisor, x plus 2, times the quotient, or x squared plus 2x minus 10, plus the remainder, which in this case was 0. And again, since the remainder is 0, x plus 2 and 4x squared plus 2x minus 10 are factors of the original polynomial. Okay, and if you multiply this out, you should get that original polynomial. Okay, example 5, we're going to try a fourth degree polynomial. Our divisor is x minus 1, so k would be, remember you got to switch that sign, it'll be +1. And then remember descending order, we got x to the 4th, which is -9, x cubed is 10, x squared is 7. There's no x's in here, so you need to put a 0 for that placeholder. So we got x4, x cubed, x squared, x, which is 0, and then the constant is -6. Now if you forget to put that placeholder, you'll get the wrong answer because you're going to be off 1. You're not going to have anything for your remainder. Okay, so bring down the first term. 1 times -9 is -9. Add down the column. 1 times 1 is 1. Add down the column. 1 times 8 is 8. So remember, the result of you're always multiplying by this divisor with the bottom row, and the result goes into the next column in the middle row. So 1 times -9 is -9. We add down. 1 times 1 is 1. Add down. 8. 1 times 8 is 8. Add down the column is 8. 1 times 8 is 8 again. Add down the column, and you get 2. So our quotient is, let's see, this was x to the 4th, so this would be x to the 3rd. And then descend, so it'll be plus x squared plus 8x plus 8 plus our remainder of 2, and you put it over the divisor. Okay, so that's our quotient plus the remainder of 2. And again, if I want to check using the division algorithm, I'm going to say negative 9x to the 4th plus 10x cubed plus 7x squared minus 6 is equal to the 9x cubed plus x, negative 9, plus 8x plus 8, and then times, I messed up. I should have done, actually, okay, so it'll be the divisor. I guess the order didn't really matter, but just want to stick with the way it's written in the division algorithm. So it's the divisor times the quotient plus the remainder. So when we write it this way, we don't write 2 over x minus 1. Okay, so if you divide both sides by x minus 1, you'll get this answer here on the right side. And then this would be the question, basically. Okay, so again, I'll leave it for you as an exercise if you want. Multiply this out, and then you'll get 9x to the 4th plus 10x cubed plus 7x squared minus 8, and then plus the 2 will get you the minus 6. Okay, so you can verify that on your own. Using polynomial division to solve application problems. Example 6. The volume of a rectangular solid is given by the polynomial 3x to the 4th minus 3x cubed minus 33x squared plus 54x. Find the length of the solid. The length of the solid is given by 3x, and the width is given by x minus 2. Find the height of the solid. Okay, so we have a rectangular solid. Okay, and so basically a box. And then let's see, the length of the solid is given by 3x. The width is x minus 2. Find h. So we know that 3x times x minus 2 times h is equal to 3x to the 4th minus 3x squared minus, that's cubed, sorry, 33x squared plus 54x. So find h. So basically we need to divide both sides by this 3x, x minus 2, and that'll get us h by itself. So h is 3x to the 4th minus 3x cubed minus 33x squared plus 54x divided by 3x, x minus 2. Okay, you can distribute that and use long division. I think what I'm going to do is I'm going to do synthetic division and divide these two first, and then it's just as simple as dividing it by 3x at that point. So So two ways you can do this. You can distribute the 3x and then use long division, the top divided by the bottom, which would be 3x squared minus 3x. Or what I'm going to do is I'm going to do the top divided by x minus 2, so using synthetic division. So basically like reducing a fraction here. So let's see, I'm going to put 2, this is my scratch work here, 3, negative 3, 4, 3, 2, 1, negative 33, 54, and then you got to put the 0, the placeholder, for the constant term. And then let's see, we get, bring the first term down. 2 times 3 is 6. 6 minus 3 is 3. We're adding negative 3 plus 6 is 3. And then that'll be 6 again. So negative 33 plus 6 is negative 27. Times 2 is negative 54, which is 0. 0 times 2 is 0. So again, it goes in evenly. So now, let me move this up. Now I have, so basically I just did the top and I divided out the x minus 2 and I'm left with, let's see, this was x of 4, so this is x cubed minus 3x squared minus 27x. And then I'm going to divide that by 3x. And since this is a single term, I'm going to divide each of these by 3x if I can, which I can. So 3x cubed, so think of it as I'm splitting it up into 3 fractions. So 3x cubed divided by 3x is x squared. 3x squared divided by 3x is just x. And then 27x divided by 3 is 9. And the x's cancel. Okay, so that's my height. So h is equal to x squared minus x minus 9. Okay, so I was looking at the way the book did that one, and what they did is they took the 3x out of all these terms first and canceled 3x first and then did synthetic division. That works too. That works just as well. I tacked it the way I did first, worked great. So either way, again, and then another way is you could have multiplied these and did the long division. That's probably the longest way. All right, and that brings us to the end of the section. So like always, I want you to practice, practice, practice. Do a whole bunch of exercises. Do at least the odds. Turn those in, and then do some extra if you can. And I'll see you next time. Have a great day.